Sooner or later, everything ends, and this can be either a good or a bad thing, depending on the situations and perspectives. For example, in the case of our planet, it might not be very pleasant for us, but Earth is not eternal, just like anything else in the universe. So sooner or later, Earth will come to an end, at least as we know it today. But when and how will all this happen? Let's try to understand. The good news is that Earth still has a lot of time ahead. At least on the scale of human time, it's a really long time, so we don't need to worry about its end right now. The fate of Earth is closely tied to the fate of the Sun, of course, leaving aside all the other potential mishaps that could go wrong. In principle, other catastrophic events, though not very likely, could occur, such as a nearby supernova explosion, a bombardment by large asteroids or comets. Additionally, there's the role we humans play in the Earth's environment, its evolution, and its change, which has become very significant, and certainly has an impact. But in what we are about to discuss, we will overlook these aspects and focus only on the purely astronomical aspects related to the evolution of the solar system and the Sun. The Sun formed about 5 billion years ago, and Earth formed a bit later, so Earth is about 4.5 billion years old. According to stellar evolution models, the Sun should still have at least as much time ahead of it. Therefore, the Sun is roughly halfway through its natural life. Now, it's important to note that stars, and the Sun in particular, operate by burning hydrogen in their core, producing helium through nuclear fusion reactions. What happens when hydrogen is no longer sufficient? This will happen in many billions of years, but at that point, the Sun will become a different type of star, a red giant, which is much larger than the Sun. During the red giant phase, the Sun will be so large that it will likely engulf the inner planets of the solar system, including Earth. Of course, this assumes that the inner planets still exist at that time and occupy exactly the same orbits, which is by no means certain and is not easy to predict, as the orbital dynamics of the planets are quite complex and can undergo migrations, changes, and shifts. So it's not easy to know if Earth will still be in its current position. But if that's the case, I repeat, Earth would probably be engulfed by the outer shell of the red giant. What happens next? After this red giant phase, the Sun will become a white dwarf, a very small, dense, and compact object that no longer produces energy and simply continues to cool down, dispersing the heat accumulated during the previous phases. Note that the Sun will not become a black hole because it doesn't have enough mass to collapse into one. It will stop at the white dwarf stage. If someone could observe this event from very far away, they would see, in addition to the formation of the white dwarf, the formation of a planetary nebula, that is, the material expelled by the Sun during this final phase will form a very beautiful, colorful, and scenic cloud to behold. Nebulae are among the most beautiful and photographed objects, even by astrophiles and astronomy photography enthusiasts. However, the solar system, as we know it, will no longer exist. All this, that is, the red giant phase and what happens afterward, should occur starting from about 7.5 billion years from now, according to theoretical models, which are now very sophisticated and can make these calculations with great accuracy. By the time the Sun becomes a white dwarf, the inner planets of the solar system will no longer exist, as they will have been swept away or engulfed during the red giant phase. The outer planets might have survived, but at that point, they will be completely different from how they are today. The gas giants, for example, might have lost much of their gaseous component and become smaller, with only their denser, solid core remaining. In summary, the entire architecture of the solar system will be very different from the current one. Even before all this happens, however, Earth will have already become uninhabitable. To understand why Earth will become uninhabitable long before the Sun becomes a red giant and then a white dwarf, we must consider that the Sun's luminosity is not constant over time. It increases with the passing years. The Sun becomes increasingly luminous as it burns the hydrogen that fuels the nuclear fusion reactions within it. This might seem strange, but it's because to counteract gravitational collapse, it needs to burn more intensely. When the sun formed, it was about 70% weaker than today. This raises some doubts about Earth's history, as some models suggest that Earth in the past should have been much colder, even referred to as snowball Earth, because Earth would have undergone complete glaciation phases. For Earth's future destiny, it's important to understand that the sun increases its luminosity by about 1% every 100 million years. This is a very slow rate on a human scale, and it should be noted that this increase in the sun's luminosity has nothing to do with global warming caused by human activity and fossil fuel use, and the greenhouse effect produced by carbon dioxide released into the atmosphere. However, in the long term, this increase in luminosity will have an effect on Earth's climate. In about 1 billion years, the sun will be about 10% brighter than it is today, and if everything else remains the same, Earth will be much hotter. The average temperature on Earth will reach about 50 degrees Celsius. This disregards everything that might happen earlier, including global warming caused by human activity. So, in about 1 billion years, this temperature rise will rapidly lead to the evaporation of the oceans. The water vapor that enters the atmosphere will further heat the planet, as water vapor is also a greenhouse gas, producing a runaway greenhouse effect. Earth will become increasingly hotter until the oceans evaporate completely. At that point, Earth will be very similar to Venus today. That is, a very hot place with a dense atmosphere and a strong greenhouse effect, and likely uninhabitable for surface life. There might be very resilient organisms, bacteria capable of adapting to these conditions, but Earth will no longer be the planet we know today. Naturally, at that point, it is unlikely that there will be humans as we know them today, and even if there were distant descendants, they would be completely different from us. Consider that our species, Homo sapiens, is about 200,000 years old, so 1 billion years is a really long time even on the scale of biological evolution. Subsequently, in about 3 billion years, Earth will become even hotter, still due to climatic effects and the increase in the sun's luminosity. At some point, it will exceed 150 degrees Celsius of average temperature, a temperature considered unsuitable for life in general, even for the most resilient life forms. Most likely, at that point, there will be no hope for any form of life on Earth, and in 4 billion years, Earth will be so heated that it will no longer have a solid crust, becoming a glowing ball of molten rock. So, the solar system has a few billion years ahead of it, but much earlier, probably within 1 billion years, Earth will no longer be suitable for life as we know it. It will no longer be the beautiful blue marble we see today from space, but a desert, inhospitable place and definitely unsuitable for life. In summary, the moral is that Earth will eventually come to an end, but the good news is that we won't be around at that point. If there are our very distant descendants, it will be their problem to face this situation. In the meantime, we should be much more concerned about the effects of our activity on the planet's environment and its climate. These are the issues we should consider and try to address in the best possible way. Thank you for watching. Leave a supportive like and subscribe to the channel. See you in the next video.